Good morning or already afternoon, ladies and gentlemen. Now we have 2 sessions coming up, and us being before NASA, I think we have a big job ahead of us. That's always really impressive. I'm looking forward to that presentation as well. But today, my name is Egle. I'm CSR manager for Elis Cleanroom, and today we will talk about our field of expertise, cleanroom garments, in the context of CO2 emissions, in the context of climate change, and then my colleague will take over presenting an innovation that we have in the group, which also has something to do with CO2 and how it affects an individual user. But I will start with talking more about, in general, about textiles and what choices can you make as a user, or we as a garment supplier, to make sure that our garment choices are sustainable. So, the big question is, can cleanroom garments be a part of climate change control? The answer is yes. And there are many ways, many choices you can make to make sure that that happens. So today we'll go through 5 choices towards sustainability throughout the lifetime of the cleanroom garment. The main choice you can make, and the biggest choice you can make, is when choosing an actual garment solution to be going either for a circular solution or a linear solution. What are those? A circular solution is when a garment is designed, it's produced, and then it goes into a circle of delivery from a supplier to a customer, usage, washing, sterilization if needed, and back to the customer again. So this circle continues as many times as is possible throughout the garment's life cycle, because it's very important to keep the garment functional for as long as it's possible. And I know that in cleanroom environment, it is not as easily done as said because there are strict restrictions. However, I'll get back to that. It is possible to extend the garment's life cycle and to have it validated as well. Whereas when the garment reaches the end of its lifetime, inevitably, there are also choices. We do not throw it away. We can reuse it at certain instances, but we can also recycle it into new textiles, into industry products, into downcycle, into energy fuels. So actually, there are multiple ways to reuse and recycle the garment when it actually reaches the end of its life. And if we recycle the garment back into textiles, it comes feeding back into the main circle. So that is a circular economy, that is a circular garment solution. Whereas a linear solution is basically a line. You produce a garment, you use it, you throw it away. That is not very sustainable. And I have the numbers to prove it. This is actually a slide about a life cycle assessment of cleanroom garments, reusable compared to disposable. It has been done a few years ago, where they measured the environmental impact of a garment throughout its life cycle. And without going into details about it, the main conclusion was that a reusable garment solution is, I think I have a pointer as well, nice. A reusable garment solution is substantially lower in energy use, in average 46% lower in energy use. Overall carbon footprint is also 42% lower, 75% lower in water consumption. We know that manufacturing textiles is very intensive in water consumption. And naturally, almost 100% better in waste generation, because you do not throw the garment away after this use, you reuse it and reuse it again and again. So, and this analysis does not take into account even the reuse of water in washing processes, because most of the modern laundries actually nowadays, they reuse the water again from the rinsing cycle to the beginning of the washing cycle. So it's actually clear to see how much more sustainable a reusable garment solution is. So this is, ladies and gentlemen, your first choice, choosing a linear or a circular solution. The second choice is, as I've already mentioned before, extending the lifetime of the garment as many cycles as possible. How can we do that in a validated way for cleanroom? Oh, sorry, actually, no, that was extending the lifetime of the garments by maintenance and repair. We'll go to the lifetime in a second, but first of all, let's talk a little bit about maintenance and repair. During its lifetime, it's natural the garments might be damaged, they might break, there might be a hole or a tear in the garment. That is okay. There are actually validated ways to maintain and repair cleanroom garments. I hear a lot of people saying that, but no, cleanroom standards do not allow garment repair because it can compromise contamination control. That, ladies and gentlemen, is not really true. One of the main cleanroom standards, the IST recommended practices, they have a whole section about garment repair. And this section states that the user, the operator, you, and the processor, the laundry, us, should agree on all repairs by means of standard operating procedures. They have to be, of course, written down and agreed upon, that specify what kind of repairs can be made, what kind of areas can be repaired, how many repairs can we have per garment. Everything has to be specified. And then it is actually okay to repair garments. And our internal tests have validated that the particle filtration effect of repairing a garment, it does not have a big impact. It does not have an impact of particle filtration if the repair is made according to the standards. That will help extend the lifetime of the garment. That will make the solution more sustainable. And now, what I was trying to get to before, extending the lifetime of the garments by establishing maximum lifetime validation. The Annex 1 clearly states, the latest version, that maximum lifetime of the garments should be established and should be written into contamination control strategy. But how to do that? We at Elis actually have performed a long-lasting test during the last, I think, 2 or 3 years. We've been taking 4 or 5 of the most used fabrics in the cleanroom industry in Europe out of circulation at our customers, actually. We have taken them out of circulation after 20 cycles, 40 cycles, 60 and 80 cycles. So they have gone through these cycles, and they also had the actual wear and tear from being used. And then we did, each time we did tests, Helmke drum test for showing how much particles does the garment shed. We also made body box tests to show the integrity of the garment, how much it retains the particles. And we also did visual examination on fabrics and buttons and zippers. And, ladies and gentlemen, the conclusion was that even after 60 cycles of wash and sterilization, the garments were still within the specifications. So there is no need for an artificial deadline for a garment. And I know a lot of our customers we work with, they set a garment at the deadline for the end of lifetime at 50 or 60 cycles. There is no need for that. We can extend it to 80 because it is validated. They can be used. The integrity of the garment is not breached, and there is no risk of contamination control. This way we can extend the lifetime of the garment and make the solution even more sustainable. Choice number 4, select a value-adding end-of-life solution. And this is a very important point because, like I've mentioned before, producing textiles is a very, very resource-heavy process. I think it's number 2 or 3 industry in the world after the oil extracting industry in terms of pollution and resource consumption. So we do need textiles. We cannot avoid that. However, we have to make sure that we use them for as long as possible, and at the end of their lifetime, we treat them responsibly. What are our choices? A little bit of theory here. European unions, or actually not only European unions, but the European communities waste hierarchy claims that, first of all, we have to prevent waste of being created, and that means, again, using the garment as long as possible, and preventing it from becoming waste too early, reusing it afterwards, if possible. And we know in a cleanroom situation, it's not always possible to reuse cleanroom garments directly. It's not a garment you would use so much in other industries, right? Then we come to the recycling part, and this is the main part. Here we have multiple choices. We can turn garments into new textiles, we can turn garments into industry products, we can turn garments into, resew them into, let's say, bags or different kind of products. Choices are limitless. And then we have energy recovery. If no other option is possible, we can always use them for creating alternative fuel pellets that can be used in various industries. For example, some cement and metal industries use these kind of pellets, which is a process where they actually reuse the byproduct and recapture carbon. So energy recovery can also be quite a sustainable choice as well. And naturally, some of the products we use will never be able to recycle, and we have to still landfill them. And this is something we would try to avoid by designing them, going back to the drawing board and designing them to be sustainable. So, having said that, we try to reuse as much of the textiles, recycle as much of the textiles as possible. I'd like to show you more or less a concept how it works. So all the textiles that our customers use are collected in a sustainable manner, streamlined manner, from the plants to a collection hub, which then redistributes them, either to reuse. For example, charities could be an option. Global Medical Aid, we have a cooperation with them where they send used cleanroom garments to the countries that have a need for doctors and nurses using them. Then, of course, recycling is a big part of it, where everything goes, and I'll show you a little bit more practical things afterwards. And non-recyclables can be sent to energy recovery. Now, here's a short film about how a garment is taken out of circulation. So basically, the button is pushed, that's it. We cannot use it any longer. It goes to sorting facility, where the lovely ladies help us a lot with sorting the textiles and seeing what can be reused, recycled, or sent to energy recovery. And then you can see they separate mops from the garments, and then they are being cut into pieces by huge recycling companies, shredded. They go through various processes, and thus then they can become into felt. And felt is used for either filling textiles like thermal jackets, or insulation materials, acoustic materials, car interior, furniture, anything you like. This is a very valuable, actually, commodity. Yes. So this is the journey of the garment, and these are the choices you can take, that you can make. Just, I know there's quite a lot of you, but maybe we can just show a little bit of the actual product. These are, some of them are acoustic, some of them are insulation materials that the garments can become. Here, hello Gordon, hey. Good. You can just send it around. I know there's not that much time, but just to touch and feel. So that is it from me. So I'll give the word to my colleague Arthur, who will present a very, very interesting innovation to you. Thank you.
Yeah, thank you very much, Egle. So if you have seen the letter inside the booklet, it was about CO2 reduction. So you have explained to us about the European Union or European Commission to the business, to textiles as well, you know. But I would like to talk about the operator, because also there's really some CO2, because think about actually on the sterile persons in a sterile environment, a person in a sterile environment, fully gowned up, who in this room has actually have been in a full gown, so coverall and mouth mask and everything? Quite a bit, by the way. Okay. So you probably must know that it's quite a challenge, or at least if I speak for myself, I find it quite a challenge. So really respect for the people who are executing such a job. But yeah, this is about CO2, and CO2 is basically piling up in these type of suits. So that's the reason why we are standing here. But before I continue my presentation, I would just like to show you a video. So why did we develop this beautiful product, Elis Air? You see a couple of things over there, product and process protection, because it all starts there, because you need to protect your own process. And on the other hand, I need to be honest, first we took there the line and the sentence saying, protect the operator. But this is not a PPE product, so that's the reason why I've put here comfort for the operator. And there were already a couple of things or elements in there which I will address again. But I think it's really important. So first of all, 0% skin exposure due to the Annex 1 is also telling, or the new regulation, telling us about that skin exposure is a no-go area. Also, reduced push-through of body fluids because you have a regulated air system inside in a controlled manner. And if you can recognize when being in such a garment and doing your activity, working activity, you become sweaty, of course, and that's, of course, then increasing the CFU level onto your garments. So therefore, and that's also back into the Annex 1 as well, 0 CFU. Due to the use of textile, it has been in a controlled manner, the particles are being flushed through this textile. Less risk of human errors, because you can imagine if you become sweaty and doing all your working activity, your concentration is going lower and lower, but if you feel comfortable, then you can still concentrate on your work. And if you think about what the people in cleanroom environments need to do, it's really precise, and it's really important if you either on microelectronics or life sciences, pharmaceutical industries or whatsoever, really important. So therefore, important measure to take into account. Improve focus on the job, as I already said. And actually I already said this as well, because using this textile in a controlled manner, the air will push it gently through the fabric itself. But also on the comfort on the operator side, because we have done some studies and tests on external institutes where we can prove that the CO2 concentration in a regular garment or in a traditional garment system is at a certain point, but using this type of system is going up to 80% of reduction on CO2 level inside the garment. I will show you the numbers later. Also, I will show you also the device. I brought the device in here, so I'm going to gown up and show you the actual device, how it works. So I'll try to wander a little bit around so that you can properly see it. But there is actually a laminar airflow in front of the operator's face, and the air is pushing through in front of the face, so the exhaled air by the person itself is pushed down, and that you constantly are breathing in the fresh air being sucked in from the clean room environment. So the purest air as you can imagine. Also, as you can see, yes, the pointer is working, where you see some condensation issues appearing. I think I can see some people already nothing about this. And you know, I mean, it's not only the personal or the goggles itself, but also personal glasses, for instance, which not always fitting, for instance. So no condensation or no steaming of the goggles will appear if you don't need to wear them anymore, of course. All these different type of goggles which do or do not fit, because there are a lot of goggles out there on the market, and some of them are really great, but do they all fit our faces? And the answer is no. So end of the day, you need to decide as a company for something, but yeah, this is something that you can eliminate then for sure. No pressing points on face, because in some environments you need to be quite a long time. You need to finish off the batch. I've heard some clean room environments that they actually need to be there for 5 or 6 hours in there, and that they are wearing these goggles, trying to fixate it very firm to their head, and then they have these pressing points in the forehead and getting actually blisters on their head, which is an issue. And the personal glasses will always fit, because right now also with these modern models becoming bigger and bigger, these goggles or separate glasses will not fit any type of goggle on top of it. And reduce perspiration. So if we see, there is actually a norm. There is also a norm actually as in the rooms as we are right now, and there it's already saying something about if you are about 2000 ppm, you already get a lack of concentration problems. And of course we are talking about a room which is like this kind of compartment, obviously, in the helmet system, but there is also a norm on the respiratory helmets, and this is what it says. So actually you could have then peaks, maximum peaks allowed of up to 35,000 ppm, and ppm stands for particles per minute, and this is where the Elis air ends up. And also not to forget, where on average, that has been tested as well, the regular garments, so the regular coverall with the mouth mask and a clean room goggle, they're on average on this level, 27,000 ppm. And it's, of course, it's high, but it's the way it is until now. And so, yeah, this is something that the people, the operators need to deal with every day and need to execute this precise work. So, how does it work? A slide on this, and then I will put on this particular helmet system, and then I will just talk through what I'm doing. So as I said, it's making a controlled laminar airflow in the front of the operator's head. It's pushing, so it sucks the air from the clean room environment through the hole on top of the helmet. It pushes through and it distributes evenly in front of the face of the operator. And then the CO2 level is being pushed down, and you have constantly fresh air that you are breathing in. And I said this previously on the fabric barrier that is pushed out as well. So now the magic is going to happen. Yeah, how should I do this? Huh? So this is the helmet. It's only this and this, battery and a helmet. And inside we have a textile, because of course it's a polycarbonate system, so it's really firm. So if you push it really hard onto your forehead, you still got these pressure points. That's the way we created a kind of a cushion, a textile that can be fitted in many ways onto the helmet on 5 fixation points. It's actually kind of, you have a couple of fixations on the side to be fitted to all head circumferences around the world. Actually, that's what we have tested. So that is something that you have here, so 3 positions over here. And then on the back of our head, you can just maneuver this a little bit wider or smaller, and you can adjust here by the wheel firm to your head as well. For ladies or for gents with a ponytail or whatsoever, we also have created here kind of a hole that you can still have some room left to put your hair through. So yeah, here's the fan system. So this is actually where the air is being sucked in from the environment and pushed all the way through this kind of cyclone and distributed evenly on this system in front of your face. It has some alarms in there, so it literally also tells you when the battery is empty or about to be empty and all that things. There's a battery, it's having a lifetime of 6,000 working hours in total as a lifetime. So what I'm going to do now, I'm going to insert the battery. It starts to beep, and then some lights will turn off or on, and the fan is starting to move. And now it's green, and now it's turning blue, and it starts recognizing that there's actually no pressure around him, because he wants to have this pressure or my breathing or anyone else's breathing, and then it starts, so it's still moving, but it notifies me right now that he doesn't feel pressure, so therefore you need to close the helmet more off as a compartment so it recognizes it. And it's based on my own pressure, let's phrase it like that. So the more I breathe, the heavily work activity I'm executing, the more he's getting me the air inside. So I'm now putting it onto my head. Maybe I should just walk around a little bit. Oh, it starts to move already, my work activity, of course. So I'm trying to fixate it now onto my head. And I have put this on the wheel. What will be my route? All right, let's go over here. Hello, everyone. So it's quite fixed now to my head, so I can headbang a little bit as well. Do one more round. And it's still beeping, of course, because no air pressure, right? So now I'm going to go back, and then we'll put onto my helmet. And the fan is still moving. So again, this fan part, I will first explain also the hood. The hood has a zipper around, fully around, and it has an airtight zipper around. So that's also what we tested in our body box system. That's also what we test with the smoke study, to literally put smoke inside, not Marlboro. Be aware of that, but just regular smoke to see if there's leakage inside. The zipper is all the way going down here. This is the inside of the hood, by the way, just to let you show properly. So the zipper is going further than actually the block. Why? Because any particles could be any problem. And then here we have a textile flap to secure it even more, but also to put in the chip for full track and traceability and put a label on top of it. So I'm now closing it up with 2 stud buttons. I'm now going to turn it outside out, the hood, so bear with me. And then I'm kind of show how you can expect it from the laundry, because I'm not the greatest folder. So this is the outside out, going inside the hood itself. So what we're doing, there's a rope inside. So it is going to be delivered like this. So at one end it's protecting the visor, and on the other end it's also protecting the visor. But if you are releasing it from the package, then you only touch the inside. That's of course really a prerequisite. So as soon as you grab it, you need to go inside, because there is a magnet in here. And this magnet is being attached on top of my hood. I will do that in a minute. And then on both sides, you see those poles on the side. I have on both sides, I have some stud buttons, so there I fixate, so I get a curve around for a panoramic vision around to see my work activity. And then at the very last stage, I'm attaching the rope to make this compartment. He will recognize the compartment and then give me the air which I needed or need. So I'm going to connect it. So it's now fixated. It's quite firm, so I can just even move around right now. It doesn't fall. And now I have on one side, I have these poles, and it's also that you can still grab it on this side. And then I'm looking for this stud, and then connect it at one part. Then I do the other part. Put it here, touch the inside still, and then to slide it over my head. So there I'm at. And now I'm going to, so it's still blue, as you can see. And now I'm going to close it up. And you see it's steaming a little bit, but now it's trying to move. And actually I need to, so it now starts to move more. So maybe I should walk around a little bit. And also bear in mind, because there's a light indicator in front of me right now, that is because this is still a mock-up. We're going to launch it in the mid of June. But the thing is that right now we already got some discussions about, hey, this is something which disturbs, of course, in your work field. So that's the reason why. Let's go this way, that everybody can see me. Yeah. And you can still hear me, so that's the beauty of these microphones inside. Yeah. I should actually, can you go further on with the clicker, please? Then I can already, because I don't know how much time we still have. I'm still smiling and I'm still walking, so. So yeah. So it's an easy aseptic gowning due to an all-in-one garment ventilation system. If you allow me, I will do the presentation further like this. It's also good fun, right? The highest contamination control level reached as well. Because it's a closed concept, eliminating the skin exposure has been set from the Annex 1 as well. Less CFU, as I said previously, but giving more comfort basically to the operator itself. So also for these sampling points, I'm not saying that we are about to reach it for everybody, of course, but I think it fosters the way that we would like to be as a whole industry. Up to 80% reduction, as you saw this part on 27,000 ppm in the traditional garment. And right now, with maximum peaks from the Elis Air on 10,000. Lower risk of human errors due to the fact that I'm feeling more comfortable right now and the presentation is going well, so still not errors, so to say. No condensation nor fogging, I still have a clear sight due to this panoramic visor. And this is, by the way, this visor is not even having an anti-fog layer. So it can also have a long lifetime in that sense. And no cleanroom goggles needed anymore, and your personal glasses will fit as well. So, step into a new era of cleanroom innovations for sterile manufacturing, and it's pure air, and I still have clear vision. Thank you very much.
Thank you. That was a great presentation. That was really good, really interesting, very different. Nice to see something different. Any questions? Any questions from the audience? You lost out, Gordon, just first. Yeah.
Is there a filter on the top, or have you considered putting a filter on the top?
I will just
at the air intake.
As I can enter here properly. Sorry. Say again.
Oh, you can't answer it. Is there a filter on the top, or would you consider a filter on the top?
No,
I know
no.
it's clean room air, but as a chemical engineer, I know there are risks. Yeah.
Yeah, but there's not a filter on top of it because it has a lock inside, so it's only the pure air filtered which is coming constantly from outside to the inside. And And it's not a PPE, so we're not having a filter on top of it yet. Maybe that's our phase 2, but that is maybe something in the future.
Gordon Farkas, and I'd like to ask you a question, actually not directly about the device, but more about, do you characterize the performance of your garments? You talked about body box. Egle talked about that a couple of times in the presentation. Are you using that, for example, can you state particle dissemination after 25 washes from your garment system into a clean room that could be used in this source strength calculation that we talked about yesterday and we're going to hear more about today for ventilation design?
Mm-hmm. Yeah.
Is that something that, because there isn't a standard really for quantifying that. So you've got Bill White stuff from years ago, you've got Lundquist and Reimüller work in body boxes and so on, but there isn't a standard approach.
Yeah, what we did a lot of body box tests to use it actually as a comparison study to traditional garments and this garment with hood, without hood, even with and without mouth mask as well, to see actually where we are standing.
Okay, so you've done that internally, if you like.
Yeah, absolutely.
But as a supplier of garments, do you publish information about particle dissemination from operators in your clean room uniforms doing some simulated good clean room behavior?
Yes and no, because we give tests, but still there are a lot of variables, because the test that we have been executing doesn't necessarily mean that it will happen at the same manner at our customers, because when I go into the body box, it will maybe generate different results than when Egle is going into the box.
Yes, because every human is different.
Yeah. So, but based on this, and that's why we are doing it all these tests at one day to eliminate as many variables. So yes, and these tests we are making those external. Yeah.
Okay. Thank you.
Yeah.
Arthur, hi.
Hi.
How sustainable is the Elis Air? I mean, it's plastic, I guess,
Polycarbonate.
Polycarbonate.
Yeah.
So is that within your? They're inevitably going to break. Some of them are going to break or you can't repair them. So are they in your recycling program? And then the battery, like what's the life of the battery and the disposable process for that?
The battery lifetime is 6,000 working hours, and the helmet actually, we do not know yet, because it's not yet in service. So we have the expectation that it will last definitely for 3 years, but we think that it will last longer, because indeed we can do still repairs. There are a couple of elements on here, like these poles, which these will most likely break. And these can be easily repaired, so this will be supplied. But other than that, I mean, if there's something breakage on the electric part, I'm not sure if we can still fix that. So we haven't not thought on the helmet part in a sustainable way, not to this point, because we simply do not have the experience yet.
If I may, we just formed a work group to see how different parts can be reused, recycled at the end of their lifetime, because our field of expertise is clear. It's the garments and all the accessories. We have a good solution for those, but this is a new and complex product. What we try to do is manufacture it from as few different materials as possible, so at the end of the lifetime it's easier to say, okay, this we put here into this bunk and then we recycle it. But we actually have a work group that's looking into each different part, which for us is not fully understood yet, how we will handle it at the end of its lifetime, because it is important that that we have a plan.
Like the end of life.
Yeah.
Especially with the battery and things in there.
We know that
this is actually what we know. For the textile part, we already know because you done a lot of good work on that. But this is actually also really brand new for us. I mean, we're a textile laundry, and not. Now we are also a provider of an electric device. So it has been a very long journey, and there must be somewhere incorporated this sustainability. But we simply do not know yet what.
We know that batteries and accessories, they can be recycled in other industries. However, we have to build kind of an infrastructure or logistics around it, how we handle that, but we are looking into this,
Okay, thank you.
Hi, I've just got a question about the headpiece. Is there a way to get this cleaned or sterilized? What is the process with that?
Yeah, you can wipe this with IPA. So, and we are coming with a manual how to do it properly. Yeah.
Great, thank you.
I'll do one more question. There was a lady at the back. You still patient? There you go.
Sorry. I have some questions to both sides on the garmenting. Typically, the garments have a carbon filament in them, which helps with static when you're working with powders. I don't know how you recycle. In the video, it was industrial and the pyjamas that were being recycled, not the suits with the carbon filament. Do you strip that out? Is that recyclable? And in terms of the air suit there, I'm not sure if I'm missing it, but it doesn't look like it's got carbon filament in that hood that you had on.
Yeah, it does.
It does. Okay.
Yeah.
Okay.
Well, it's a topic I could talk about for 2 hours if you have that. No, but very shortly, it depends on the technology. The shredding mechanical recycling technology does not care about the carbon. It's just a minor proportion. But our aim is to be able to recycle textile to fiber fully, which means that if we want to manufacture new cleanroom garments, we need very high quality polyester, which mechanical recycling does not give us at the moment. So what we're looking at is thermomechanical or chemical recycling, and there it depends very much on the technology. Older technologies cannot handle carbon fiber, but now I know, but I'm a part of a lot of European-wide projects that focus on this, because it's not only us, it's the whole industry that needs good quality polyester. Newer technology exists that now the primary tests have shown that actually carbon can be handled, but it requires the newest technology actually. So, because that's a very good question. Carbon has been a big point and a big challenge for recycling these garments, but it seems like now there is technology to handle it. It's still in R&D or small scale, but actually that was a happy day for me when I found out actually that it is possible now.
Okay, thank you. That's it. If you've got any more questions, you can touch base with these guys outside of here. We need to, we need to move on to the next presentation, I'm afraid. So thank you very much. That was really good. Round of applause, please, guys. Thank you.